Hello, this is Mrs. Huntley. You are in Module 4, Linear Relationships. This is a video on proportional relationships, so I would like you to get your supplemental packet that has this on the front cover and turn to the page that in the top left-hand corner it says Linear Relationships Student Handout 4, and then we have this title here of Proportional Relationships. I'd like you to add the essential question at the top: how do I know if a relationship is proportional? And then we're going to do some fill-in-the-blank notes, a couple of examples together, and I will be explaining what it means to have a proportional relationship. So first of all, a relationship between two quantities is proportional if the ratio between the two quantities is constant. What does the word constant mean again? It means it's going to be the same. It's going to be the same amount of change at each interval. Remember we said slope was the ratio of the change in y over the change in x, so it's going to be the same ratio or the same slope throughout for it to be proportional. Two things are true about a graph that is proportional. First of all, the graph will be a straight line. So when I'm graphing the data, it's going to all line up and I'll be able to connect the data using a straight edge. Secondly, the graph has to pass through the origin. If it doesn't pass through the origin, even if it's a straight line, it's no longer proportional. The last part of our fill in the blanks, in a table, we want to check for equivalent ratios. In other words, in a proportional table, the ratio of y divided by x will always be constant or the same. It's going to be the same number. Remember we said slope is a ratio of the rise over the run, change in y over change in x. For it to be proportional, that change, that slope, has got to be constant. Let's look at some examples, and I'm sure this is going to make more sense once we have some examples to draw on. Our first example, Hillary is looking for a gym to join. The one gym offers a membership for $25 per month. Use this information to complete the following. We have a table and we have a graph. So let's start with the table. It says complete the table to show the relationship between the number of months at the gym and the total cost of the gym membership. So we have to decide which is our x and which is our y, which is independent of the other. Now the number of months that Hillary is going to the gym is going to be independent of the cost. The cost is going to depend on the number of months because we're paying $25 per month. Depending on the number of months will depend on the total cost. For example, if I've got 25, because that's what it costs per month, times 0 months, I'm out 0 money. If I've got 25 times 1 month, it's going to cost me $25, etc. So go ahead and pause the video, fill in the rest of the graph using our x values and multiplying it by our $25. Okay, so the next question about this says, what is the slope or rate of change shown in the table? And I can figure that out. Some of you might already know it because this is pretty easy math. I can figure it out by taking my y, dividing by my x. Then I should take my next one and divide it by my x. Make sure it's going to be constant throughout the table. Okay, so 25 divided by 1 is indeed 25. 50 divided by 2 is 25. 75 divided by 3 is 25, and 100 divided by 4 is 25. Now we knew that it was going to be constant because I was multiplying by 25 throughout the table. So what is the slope or rate of change in this table? It's going to be 25. Is the table proportional? Yes, the table is proportional, and it tells me to explain. So I'm going to say yes, the table is proportional. The ratio of y divided by x is the same for the entire table. Okay, so that's what makes it proportional, is that ratio is the same. Now I'm going to use that data. I'm going to go ahead and graph it. Now these are my x's, these are my y's. So I'm going to create the graph. Now I've got to label my graph. Now they numbered it for me, which is great, but there are no labels here. So I'm going to say that my title of the graph is the cost of the gym membership. My X is showing my number of months. And my Y is showing my total cost. So at 0 months, $0. 1 month, I go up to halfway between 20 and 30. Now, what I tend to do, because it's going halfway, I could go and do, no, I'll just continue this way. So at 2, I'm going up to 50. At 3, I'm going up to 75. So again, that's halfway between 70 and 80. And then at 4, I'm going up to 100. Now you should use a straight edge when you're connecting these. I don't have a straight edge, but I do have a tool that allows me to draw straight lines. So I'm going to go ahead and get a blue line, and I don't want it super fat because I want to be able to see my points behind it. So I can draw a straight line through all of my data points. So it says, what is the slope or rate of change that's shown in the graph? Now, I know because I just graphed my data. Well, hang on a second here. My line is off a little bit and it's bothering me. There we go. Okay. It's important to have a nice straight line because when you are counting slope, it will make a difference. So it says, what is the slope or the rate of change shown in the graph? Now we know that it's going to be 25 because I just graphed this data, but I want to show you that when you have a graph, you may be given a graph and being asked to find what the slope is. So let's go ahead and do our rise over run. So being that this one is in the middle and I can't tell exactly what it is, what I'm going to do is go ahead and grab those integer coordinates again. I'm going to go from 0 up to 50 and then over 2. So what is the slope or rate of change? 50 over 2. 50 over 2 is 25. So my slope is 25. Now that should be constant. Every time I see integer coordinates, it should be the same. And here I'm going up 50 and over 2. This is 50 over 2. So that slope triangle should be the same everywhere on my line. Okay? Is the graph proportional? Explain. So hopefully right now in your head you're screaming, yes, of course it's proportional. So yes, it's proportional. How do I know? What's my explanation? It is a straight line. And it is going through the origin. I can glance at a graph without knowing its slope or without knowing anything about it and tell whether it's proportional or not if it's a straight line and it's going through the origin. Okay. It says write an equation to represent the relationship between x and the number of months. Wait a minute. Write an equation to represent the relationship between x, the number of months at the gym, and y, the total cost of the gym membership. So we're going to put this in the same format that we did before. Now we could write a ratio like we were doing when we were using the Eureka materials, but hopefully we're understanding that our slope is going to be the coefficient of x. So it's going to be 25x, and y, our total cost, is going to equal 25 times x. Okay? So do you see the slope in the equation? If so, where? I kind of gave that one away, didn't I? The slope is the coefficient of x. and it's always going to be the coefficient of x. When something is written, this is called slope-intercept form. So when something's written in slope-intercept form, it's always going to be the coefficient of x. What conclusion can we make about proportional equations? In an equation, the slope will always, in a proportional equation, I should have the word proportional in there, the slope will always be a coefficient of x. So let me fix this. In a proportional, the slope will always be the coefficient of x. Okay, so we have some more fill in the blank here. Proportional equations will be written in the form y equals mx, where m is the slope. Remember I told you the other day that m always represents slope in mathematics, the variable m, and I don't know why. So if anybody wants to do some extra research and see if they can figure out why we use m for slope, that would be great. So what do the x and y represent in the equation? The x and the y are different inputs, your x's, and different outputs, your y's. These values make up the ordered pairs. They're also values that make the equation true. So if you're putting an input in that doesn't give you an output that's real or that's true, it's not going to be on the line. It's not going to be part of your solution. Okay? So let's take a look at the table below. See, here they're giving us a table that shows the cost of a certain number of pounds of cheese. So here are your pounds, here's your cost. What is the slope or rate of change? Now remember, we said that that has to be the same throughout the table. This is our x, and this is our y. So we have to check to see what $5.52 divided by 4 equals. So grab your calculator, $5.52 divided by 4, and see what you get. I get $1.38. Now I have to check, it's going to ask me if it's proportional, so I have to check each set of ordered pairs. So here we have $11.04 divided by 8. What is that going to equal? I get $1.38. Please do the last two. So my rate of change is 1.38 or $1.38. That is my slope. What does this mean in the context of the problem? Well, since I'm doing this division, it means that the cost of apples is $1.38 per pound. So this is over 1. Okay, so it's $1.38 per pound. Okay. Is the table proportional? Yes, that table is proportional. Because the change is constant throughout the table. And I'll make this to where it fits in the space. So that, how do you know? I had to check the whole table, guys, because if this last one wasn't $1.38 per pound, say that after you buy 10 pounds, maybe these last two, maybe and Sam's Club does this a lot. After you buy like a huge quantity of something, they reduce the cost per pound. So maybe if these apples were on special or something, and after you buy 10 pounds of apples, it goes down to $1.20 per pound, then it would no longer be proportional. That's why I have to check the whole thing to make sure that the data I'm given is going to be proportional. So if I'm writing an equation for the table, my total cost is equal to the price per pound times the number of pounds. Okay. If I am graphing this information, and they're giving us a graph over here, so I have to analyze this graph, okay? Notice, this is going by 2s. This is going by 1s. They didn't label my graph again, but I know that this is my pounds. And this is my cost. They really should label it. Okay, so I'm going to pick out the integer coordinates again, because that's going to be the easiest way for me to calculate the slope, okay? And it should be constant throughout my graph. Oh, you know what? I just realized, and I should have realized this because I did prep this lesson at home. Oh no, that is not what I wanted to do. Okay, there we go. This is not the graph that represents the apples, and we are near the end of the lesson, so I'm not going to re-record even though I made a mistake, but hopefully you were writing in pencil and you can just erase that. This is just a random graph, and we're using the graph to answer the questions that are below. It's not the apples. My mistake there. So notice still our y's are going up by 2s. That's what I meant to say, by 2s. And my x's are changing by 1s. And I'm finding all of my integer coordinates. And I need to figure out the slope or the rate of change. So I'm going to do some triangles. I'm going up by 2, 4. So my rise is 4. My run is 1, 2, 3. 4 over 3. Now, if my graph is proportional, I will be able to repeat that and still be on my line. So can I go up 4, 2, 4, and then run 3? Up 4, run 3, yep. And I would say if the table would keep going, that ladder or those triangles would continue going on. So is the graph proportional? Yes. The slope is constant. And the graph is going through the origin. If I'm writing an equation for the graph, my y, my output, is equal to my slope times my input, the x. Okay? So they are asking you to summarize today's lesson, and you have a little bit of space there. So what did we learn today? We learned that a graph of something that is proportional is going to pass through the origin, and it's going to be a straight line. We learned that if a table is proportional, my y's divided by my x's are going to be the same throughout the table, and that's going to represent my slope. We also learned that if we're writing an equation for a table or for a graph, we set our output, our y, equal to our input or x times the slope. Y equals mx. What we didn't learn, what we don't know, is why we always use m for slope. So anybody, again, that wants to research that, please feel free to do that and educate me in class. I would love for somebody to actually share that with me. Have a great night, and I will see you tomorrow.